We're going to now examine how to graph transformations. Our first transformation is going to be the vertical and horizontal shift. As we take a look at exploration 1, you'll notice how we have our parent function y equals x squared. Now, aside from x squared, we also have this plus 2 and the minus 2 that's affecting the equation. How exactly does it affect it? Well, it's not exactly affecting the parent function outright, but the plus 2 and minus 2 is after the fact. It's going to affect the y value or the output once you have your parent function. So if it affects the output, then that must mean that the x value stays the same, but what changes is the output, the y value, which can either go up or down. Let's examine their graphs. As we take a look at the parent function y equals x squared, you'll notice here is our parabola. And what we're going to now do is we're going to move this parabola based on that plus a. That a value can change. You'll notice that as that a value gets more and more positive, the parabola is getting higher and higher. It's going up, basically. Okay. As that a value becomes more negative, you'll see that the parabola is actually going down. So as we go all the way to x squared plus 2, the example in our paper, you'll notice here we have y equals x squared plus 2, and it's way up there, right? It's basically gone up 2 units. Versus if we were to bring that parabola down all the way to x squared minus 2, you'll see my a value is negative 2, right? We'll have y equals x squared minus 2. You'll see the parabola went downwards by 2 units. Let's examine how this is done. So you'll see that each of the points on the parent function, y equals x squared at 0, 0, 1, 1, and let's say negative 1, 1. You'll see that as we go to x squared plus 2, each of those points gets raised 2 units right here. You'll get raised 2 units. Basically, every single point on the parent function gets raised by 2 units, and that's shown in our equation y equals x squared plus 2. Versus going in the downwards motion, I just realized I'm doing the opposite colors here, but as we go in the downwards motion, you notice that each of these points are going in the negative direction. They get brought down to minus 2. So that's why in our equation we have y equals x squared minus 2. All right, now let's take a look at our questions here. So the connection between the graphs is we see that the parent function is shifted vertically by the constant term, by that plus 2, or plus a, whatever you want to call it. Okay, so we see here in our summary of vertical shifts, if we have y equals f of x plus k, the plus k is being applied to the parent function after the fact, then the graph of f is shifted up k units, versus if you have y equals f of x minus k, then the graph of f is shifted down k units. Okay, let's take a look at our next transformation. We have our horizontal shifts now. We'll see here that now the difference between this example and exploration 1 is you'll notice that the 2 is actually contained within the x. This is affecting the x directly. This affects x directly. Okay, so for that reason, we need to make sure that we apply that to the horizontal shift. As we take a look at our graph, okay, so now we'll have our y equals x minus b squared. And then what we're going to do is we are going to make that b value change. You'll notice that the graph is basically shifting horizontally. It's going right and left, like that. Okay, so the graph is now shifting left and right. Okay, so as we go all the way to the right, you'll notice that we now have the graph y equals x squared minus 2. Okay, we've gone 2 units to the right. And if we shift this graph all the way to the left, 2 units to the left, right there, then you'll notice now we have y equals x plus 2 quantity squared, right there. Okay, so those are our 3 different graphs. Again, as we examine each of these graphs, you'll notice that from the parent function, they all contain the same points of 0, 0, 1, 1, and negative 1, 1. But then what we do is we shift the graph horizontally 2 units, And so each of those points now gets mirrored over here like that. So you'll notice that this has always gone 2 units to the right, 2 units to the right, 2 units to the right. And you'll notice how we have that x minus 2 squared there. If you refer back to our equation, you'll notice that you have y equals the x minus, and then that b value would have been the 2 value. So we would have had y equals x minus 2 squared. Okay. Versus if we went to the left side, basically each of those points now gets brought over 2 units to the left, and so you'll have these points mirrored over here. Okay, and so because you're going 2 units to the left, that minus 2, you'll notice in your basic equation of y equals x minus b squared, if that b value was minus 2, then what's happening is that that negative and negative give you that positive value. So that's why that equation becomes y equals x plus 2 squared, like that. Okay. All right, let's go back to our worksheet. Okay, and then summarize everything. Now we can see that the connection between the graphs is that the parent function is shifted horizontally. And we'll call this by h units. Okay, and so you can see here that when you summarize everything, that y equals f of x minus h, that minus h is telling you to shift it horizontally, you're going to be shifting that to the right h units. Versus if you have y equals f of x plus h, then the graph is, of f is shifted to the left h units.